know that trigonometry is a topic that comes every year. So I want us to look at the introductory part. So we'll look at the first part is to look at the right angle triangle. We're going to actually say relate. So right angle triangle. Okay. Today, trigonometric ratios. And then you also look at the three trigonometric ratios. So trigonometric ratios on a right angle triangle. Right angle triangle. And then also calculate sides and angles of a right angled triangle. Okay, so these are some of the things that we're going to look at. We'll look at the relationship between the right angle triangle to the three trigonometric ratios, as well as we'll look at the descriptive of the three trigonometric ratios on the right angle triangle, and then also we'll look at the calculate the sides and angles of the right angle triangle. Okay, so for your own information, what you need to understand is trigonometry is trigonometry trigonometry simply means triangle measurement. Okay, triangle measurement. Measurements. So when you're looking at trigonometry, you are just trying to look at the measurements of a triangle. So in this case, looking back at the first point is that this one, okay, relate right angle triangle to the three trigonometrical ratios. So in order to understand the three trigonometrical ratios, we'll look at this abbreviation called SOHCAHTOA. Okay. So this SOHCAHTOA. Now this is divided into three trigonometric ratios. Okay. So for example, if I have a right angle triangle drawn here. Okay. So we have to take note of how we draw that. Okay. So let's say this is A, this is B, this is C. So from that point now, the three letters here, they represent for one ratio, and S stand for the sine function, okay, and this in the other one, C stand for the cosine ratio, and the T in that stand for the tangent, okay, for the tangent. So now, in terms of our trigonometric ratios, like the sine and the cosine and the tangent, the way you can actually relate them is that, first of all, the sine is going to be sine theta is equal to the opposite of this angle, okay, opposite over the hypotenuse, okay, the hypotenuse over the hypotenuse. Now, in this case, you have a right angle triangle, so the hypotenuse is this side. This is the hypotenuse, and these two sides are the adjacent. Now, you have to understand that depending on where the angle function is, then it will help you to find the opposite. Okay, so this is number one, and number 2 is the cosine. So the cosine is cos theta of that angle is equal to the adjacent, okay, adjacent over the hypotenuse. Okay, and number 3, we also have the tangent, which can be just tan theta is equal to the opposite, okay, opposite over the adjacent. Okay, so now when you look at these 3 stuff, you have to understand that when should you use the sine, when should you use the cosine, when should you use the tan. So now what determine which one you are going to use is you need to start with the cosine, okay, I mean the theta. So this is simply called the theta, okay. So that is the theta, and is always in degrees, okay. It is always in degrees. Is it how you write degrees? Okay, degrees, okay. So now from there, in this example, I'm going to just help you understand on number 2, like on number 1, you're saying relate right angle triangle to the 3 trigonometrical ratios. So the relationship therefore is that you have the angle this side and the sides of that triangle, okay. So that is a relationship. So this is the angle, this is the angle. So most of the time when you're looking at that, you have to be careful. Are you looking for the angle or the end of the side, either the opposite or the adjacent, or in this case, are you looking for the cos of that angle, and the sides should be adjacent over the hypotenuse, as well as also in terms of sine, are you looking at sine of that angle, then the sides are opposite and hypotenuse. So remember that when you look at this trigonometry, we are saying that right angled triangle, okay. So that should also be understood, right angled triangle. So a right angled triangle a right angled triangle, okay, right angled triangle is a triangle that is a triangle that is less than, or should I say that is equal to 90 degree. Okay, so it is always equal to 90 degree, and this symbol right here means that this triangle is a right angle triangle. And look at the way we have drawn them. This should be perpendicular, okay. This AB should be perpendicular to this line, okay. So that is basically the most important thing, okay. So if this is a right angle triangle, then we can apply these 3 trigonometric ratios, okay. So now we are moving on, and the other thing I wanted to stress out is that this line, okay, is called the hypotenuse. The hypotenuse. okay, the hypotenuse. And any of these two lines, they are adjacent, okay. So now, what about the three trigonometric ratios on the right angle triangle? Okay, so this is what we have just talked about. These are called trigonometric ratios, the three of them. Of course, there are many other, but we are just sticking to the point. This is just about this. Okay, now we want to see how you can be able to calculate the sides, the side as well as the angles. Okay, so in this example, I'm going to say you have, for instance, this is theta. Okay, this is theta, and then you have this side as 4, let's say centimeters, and you have this side as 3. Okay, now I'm gonna actually say find theta. Okay, so how am I supposed to find theta? So for you to find theta, you have to look at what you have been given. It is, there is 3 centimeters there, and also another 4 centimeters there. But the most important thing is that the position of the angle, okay, because the angle should be related to one of the sides. Okay, so we are going to say that this angle, the opposite, it has the opposite 3 there. So it has the opposite and the angle itself, as well as the adjacent side. Okay, the adjacent side. Now the fact that this is opposite, this angle, this is facing to this side, meaning this one is an adjacent. So therefore we have the angle that you are looking for. So the angle you are looking for is question mark, okay, and the opposite is question mark, and the opposite is 3 centimeters, and the adjacent is now 4 centimeters. So now how can we find now theta? So when you go back to this side, we have sine, cos, and tan, since we are looking for theta, which should be an angle. So look for something that has the opposite and the adjacent. Okay, so you discover that opposite adjacent is actually tan. So it is not that you are going to use everything there or other. Okay, so therefore our answer is now going to be, so we know that tan theta is equal to the opposite over the adjacent. So from there, we can say tan theta, the opposite now is this, is 3 centimeters over the adjacent is 4 centimeters. So from there now, you're going to have tan theta is equal to this, they go. Okay, so just means 3 over 4. Now I'm just gonna actually write here. Okay, so meaning tan theta is now 3 over 4. So from there, what are we saying? So whenever you're looking for an angle, this one, you need to find the inverse. So find the inverse, okay? Okay, find the inverse of that. Okay, so meaning the inverse of this is going to be theta equals to theta will be equal to tan inverse of 3/4. Okay, so from there now you're going to have when you punch on your calculator, you discover that it's going to give you 36.9 degrees. Okay, now this 36.9 degrees is the same as, you can just same as just 37. Okay, so that is basically the answer to this question. Okay, so that is how you can apply these trigonometric ratios. Okay, so make sure you understand that. Okay, so next now let us look at how you can be able to find out the sides. Okay, how we can be able to find the sides. So you need to find the sides now. Okay, so when you look at this example right there, okay, we don't have this hypotenuse. Okay, so we have this question mark. Now if you want to find the hypotenuse, this side AC, you can also use what is called the Pythagoras theorem, and I'm just going to show you in a minute. Okay, so the Pythagoras theorem, okay, so now the Pythagoras theorem, we have found now this one as 37 degrees, and we know that this was 4 centimeters and this was 3 centimeters. Okay, so we want to find this side. Okay, now finding this side can be done in two ways. You can use the Pythagoras theorem. So the Pythagoras theorem, something like that. Okay, so whenever you're looking at the Pythagoras theorem, the hypotenuse should always be the subject, the formula. So say always make the hypotenuse. So make the hypotenuse. Okay, so make the hypotenuse the subject of the formula. So what we mean by that, we are saying that we always say in the Pythagoras theorem, you always have to say the Pythagoras is the subject, so AC squared is equal to AB squared plus BC squared. Now from there, we can now put in the numbers that we have. Okay, so AC squared is equal to AB is 3, and then you square them, and BC is 4 squared. So from there now we can now say this is 9 plus this is 16. So from there we are going to have 25, okay, and then you are dropping down the AC squared, So from there we can introduce both sides the square root. So this and this goes, so it remains AC equals to 5 centimeters. So the square root of 25 is just 5 centimeters. So what you're saying is therefore AC or hypotenuse, the hypotenuse is 5. So that is basically how you can go about finding that AC. So that is method 1. Method 1. So now what is method 2? So method 2, we are going to use trigonometrical ratios. Trigonometric ratios, okay? We're going to use those ratios. And we know those ratios, okay? So the ratios are from this abbreviation SOHCAHTOA, okay? SOHCAHTOA. And we know that the abbreviation makes up 3 ratios. So this one and the last one. Okay. So the last one, the first one, this, so meaning this one is just the sine theta equal to opposite over the hypotenuse. Okay, and then this one, the second one, car, is simply the cos of that angle is equal to the adjacent over the hypotenuse. Okay, and the last one, which is TOA, this is TOA. So this one is tan theta is equal to the opposite over the adjacent. Okay, so from now, from this point onward, so we have this one, these 3. What do you need to understand? Okay, so we are looking for this side using method 2. And method 2 that you have talked about is using any of these ratios. So from there now, you look at what are you looking at, okay? So what you're looking at, since we are using these, that involves the sides, okay? The side and angle, okay? The side and angle. So from that now, we can say that we need first of all to follow where the angle is, this one, okay? So what you're going to do is you're going to use the opposite of this angle. So the most important thing is to look at the opposite of this angle. So it is facing to this side AB, and which has this distance 3 centimeters. So we are going to use this opposite and this angle so that we can find this hypotenuse. Okay. So we know that opposite and hypotenuse is this. Okay. So we are going to actually make opposite the subject. So from there now, we're going to say sine theta is the opposite is AB, okay? The opposite is AB, you can see there, which is AB 3 centimeters, and also the hypotenuse is AC. So you can see that their hypotenuse is from A to C. So from this now we can now say that the sine, or sine which is the angle, is 37. Okay, you can counter check please. So the angle given is 37. Okay, and our opposite is just 3 centimeters. So you can ignore the units at this point, then over AC. Okay, so what you need to do is just cross multiply by making this one a fraction. You do that. So I'm going to say sine 37, okay, multiplied by AC is equal to 3. So equals to 3. So this is going to become sine 37 AC, okay, is equal to 3. From there now you can divide both sides by sine 37 over sine 37. Okay, so from there this and this goes. So you're going to have AC is actually, we are going to divide now. Okay, so once you divide, we are just gonna actually get the same answer, which is just 5 centimeters. Okay, so you can confirm that by using your calculator. So that's how you can go about doing that. Okay, so thank you so much for watching. This is a Radical Academy, and I will see you in the second chapter of this video. Please make sure that you go through and practice this one. Okay, thank you so much. Bye bye.